Good morning, everyone. In the previous session, we have seen the introduction part of this environmental engineering one. Today, and we are going to discuss the continuation part to the previous topic. We have a look in the previous session. We have seen the topics like necessity and importance of protected water supply system, where we have seen the importance of protected water to the public, and also we have seen the objectives of protected water supply system. There we have seen the adequate water supply has to be there to the public. The quality must be there. Future demand must be met, along with the requirements during emergencies like fire accidents, fire accidents and all. Here, and also we have seen the other topic, waterborne diseases. What are the highly suspected diseases due to this contaminated water we have seen? Namely the bacterial diseases like cholera, typhoid, and of course we have seen the viral diseases and also protozoa and all. We have also seen the role of environmental engineer as part of our curriculum. There we have entered into the topic by name flow chart of water supply engineering. This is also part of your curriculum. You must learn this flow chart before you are going to examinations, and you may expect the question, write a notes or else draw a flow chart of water supply system. See, flow chart of water supply system, else flow chart of water supply engineering. See here, water supply engineering, from the source to consumer. Here, the source of water, one is surface water and the other one is groundwater. Here, surface water in the sense, the water which is available in the form of lakes, rivers, ponds, of course reservoirs called as surface water, whereas the water that is available in the deeper ground in the name of springs, wells, infiltration galleries, all comes under groundwater. See here, in the groundwater, when we have a look as part of the curriculum, here we have an in detail discussion about these wells. The wells has been categorized into 4: artesian wells, dug wells, tube wells, and infiltration wells. Again, these dug wells has been divided into 2 categories: shallow wells, deep wells. See here the ponds as well as see here intakes, else descend and descend completely. That means what I'm speaking is here descent, that and these all the sources must reach to the intake works. What is this intake? I'm going to discuss in the days to come in the coming units. Intakes. From the intakes, the water will be collected. There, the treatment will be followed. In the treatment, we may observe the techniques like plain sedimentation, sedimentation with coagulation, filtration, disinfection, miscellaneous methods and all. The plain sedimentation, that means under all these categories, after the completion of all these categories, the water will enter into the distribution system. From the distribution system, based on the gravity, else pumping, or else both the gravity and pumping, the water will be reached the district mains. From the district mains to branches or service lines and consumers, again the wastewater enter into for recycling. This is what about flow chart. See here from the source. There are 2 categories: surface water and groundwater. Surface water is available in the name of ponds, rivers, lakes, and impounding reservoirs. Groundwater in the name of springs, wells, infiltration galleries. See here again the wells, four categories: artesian wells, dug wells, tube wells, infiltration wells. These dug wells, again two categories: shallow wells, deep wells. And out of all these sources, water will reach to the place by name intake works. From the intake works, the water will be collected. After the collection, the treatment will be done. After the treatment, we may observe the sedimentation there, plain sedimentation and sedimentation with coagulation, followed by filtration, disinfection, and all other miscellaneous methods to remove the particles which may not remove in the previous methods. See, after the treatment, the water will be subjected through distribution. In the distribution, there are two techniques, or else three we may adapt. Based on the gravity, water will be distributed. By using pumps also we can distribute. By using both the pumps and gravity, we can supply the water. Initially, the water reaches the district mains. From the district mains to branches, branches to consumer. After consumption, obviously some amount of water will be wasted in the name of while utilizing the amount of water will be misused, and as which may call it as a wastewater, and the wastewater again will be subject to recycling, and from there cycle will continue. This is what about flow chart of water supply system, is flow chart of water supply engineering. And coming to the next topic, that is water demand. See here, water demand, demand of water. See here, demand of money. Okay, you may be here based so many demands. Okay, demand of water, demand of food, demand of economics, demand of money, and so on. See here, as we discussed, and as I told you, this particular EE1 exclusively, as per your curriculum, fitted and designed with respect to water. See here, water is demand. Why? Why water is demand? See here, after the air, water is the second most important parameter for the survival of any living organism on the earth. See here, as the population is increasing, the rate of water consumption also increasing at an alarm rate. Even though we are being surrounded with plenty of water, we have very limited water that will be used for consumption. See here, when the population, if the population is increasing like this, obviously the water demand will be more and more, and one day or other day the cost of water will be reached, or else may cross the cost of petrol. If the situation is like this, where the water, plenty of water is being misused, or plenty of water being contaminated because of the human activities, that is the reason the water has to be treated, and water, that is the reason the water has to be used carefully in such a way it will be useful for future generation also. See here, as per the calculations, for every human beings 135 liters per day is mandatory to complete his activities. 135 liters per day of water is required for one human being per day. See here, where see this water demand is, the water demand is not restricted to one particular area. Whole world, the problem associated with water is keep on increasing year by year due to various reasons. When we have a look more elaborately, what is this water demand and what are all the consequences of this water demand, we can categorize this water demand into the following categories. One is domestic water demand. Next one is commercial and industrial or institutional demand. Third one is fire demand. Fourth one is public demand. Fifth one is compensating losses demand. See here, now let us discuss one after one about this water demand. See here, domestic water demand. The name itself revealing to us domestic, the water that is being used in the homes, it comes under domestic water, and how the water is being utilized at the homes, we can go through this particular slide. The water which is required for the activities like drinking, cooking, bathing, or etc. comes under domestic water demand. See, as per IS IS code 1172/71, the development countries, the average in the developing countries, the average consumption per capita per day is 135 liters, and it can be divided as follows. I said that average 135 liters of water is mandatory for the daily activities of human being, and this 135 liters has been divided as for domestic for drinking purpose 5 liters, for cooking purpose 5 liters, for bathing 55 liters, for washing clothes 20 liters, cleaning floors 10 liters, cleaning utensils or as dishes 10 liters, flushing purpose 30 liters. See, on average, 45% of total required quantity has to be in the total required quantity. 45% of water has to be allocated for these domestic needs. What we are discussing about the water demand. In that, first one is domestic water demand. Domestic water demand, and in the sense, all the activities that are being taken place at home itself comes under this domestic water. And for every human being, as per the calculations and as per the code IS 1172/71, on all the developing countries, 135 liters per day per capita is required. See again, the 135 liters, 5 liters drinking, 5 liters cooking, for bathing 55 liters, washing 20 liters, cleaning floors 10 liters, cleaning dishes 10 liters, flushing purpose 30 liters, and out of total required quantity, 45% has to be allocated for this domestic water demand. See, our next one is commercial and industrial demand. What is this commercial demand? The water which is required to meet the need of industries, industries, or else commercial complexes like movie theaters, hospitals, shopping malls, schools, etc. comes under this category. See here, the industrial and commercial demand. See here, all see the activities related to commercial complexes, schools, shopping malls with respect to water comes under this act, this demand, where as per IS 1172/1963, the basic requirements for water supply, drainage and sanitary system as shown in the following table, where this is the table. See here, this is in detailed table of commercial water demand. See here, factories where bathrooms are required, 45 liters per day per capita. Factories where bathrooms are not required, 30 liters per day per capita. Coming to hospitals where having laundry beds, 450 liters per day per capita. When bed capacity is exceeded 100, 340 liters per day per capita, and bed capacity is not exceeded 100, even there also 340 liters per day per capita. See, hospitals when bed capacity exceeded 100, that is 450, not exceeded 100, that is 340. See here, medical staff quarters is 135 liters per day per capita. Hostels for every human being, one person, 135 liters per day per capita. Offices 45 liters per day per capita. Restaurants per seat 70 liters per day per capita. See, movie theaters 15 liters per day per capita. Schools 45 liters per day per capita. Vehicles or else animals 45 liters, and also for animals 45 liters per day per capita. Gardens, any sports grounds, that is 3.5 liters per square meters. This table has to be remembered by you during the examinations. Whenever you have any question, write your notes on water demand. You must write about this flowchart in this table also by splitting all various points. That means there is various areas by incorporating the required quantity of water. See here, commercial demand and industrial demand. See here, the water that is being used and that is being utilized at industries, commercial complexes, shopping malls, schools, etc. comes under this category. And this is what about detailed required quantity of water at various commercial and commercial areas, as well as at various institutions, as well as at various industries. See here, next one is fire demand. See here, fire demand, the name itself revealing to us the fire demand. Fire demand in the sense some amount of water has to be stored to bring down, that is to control the fire whenever such type of incidents occur. See here, at dense populated zones, there is a chance of catching fire due to improper electric wires, fire catching materials, explosions, and criminal attributes, etc. See here, whatever might be the reason, we must be available, we must be adequate with respect to water that will be used to control the fire. See, how can you calculate the water that is required for fire control? See here, there are different formulas. There are different formulas to adapt at the time of distributing these water requirements. Among those formulas, there are only, those empirical formulas. The first one is Kuchling's formula, where water fire demand will be calculated with this formula Q equal to 3182. 318 root 3182, where Q is quantity of water, P is population of the area, and see here Boston's formula. See here, P is not here. Here P is there, but it is missed here. Where Q is quantity of water. See Q equal 3182 root P. P is population of the area, and next one is Boston's formula, the which can be used, which can be adapted to control the fire, and the formula is Q is 5662 root P. Q is quantity of water and population, P is population of the area. Normally, the water that is being calculated for various requirements, 5% in the total quantity, required quantity will be allocated for fire control or else as part of fire demand. In the previous instance, we have seen 45% of water in the total required quantity of water will be allocated to meet the needs of the domestic purposes. And here, this is what about various needs and various quantity levels, whereas here 5% in the total quantity of water will be allocated to control the fire. And next one is here public demand. Public demand in the sense, the water that is required for the maintenance of parks, public fountains, all comes under this category. Here also 5% in the total required quantity of water has to be allocated for this public demand. And this is what about the detailed required quantity of water. Public parks 1.5 liters per square meter per day, whereas for street washing 1.1 to 1.5 liters per square meter per day, and sewers 4.5 liters per square meter per day. This is what about the public demand to be used for cleaning streets, for maintaining parks and various other public places. See here, after considering this domestic demand, after calculating water for this domestic demand, fire demand, industrial demand, see, obviously when the water is being supplied, there will be a loss of water because of the cracked joints, because of the broken pipes, because of the inadequate monitoring of pipeline system. There will be a loss of water, and that loss of water also has to be considered when the water is being calculated to meet the need of the people. And that comes under compensated losses demand. See here, under compensated losses demand, total 15% of water, the required quantity has to be allocated for compensated losses demand. See here, this is what about the water demand. Why water is in demand? Because the water is always prime important factor. Water is always considered as prime important factor for the survival of human being. Especially this water is more in demand in rural than urban areas than the rural areas. Why? Because see here in urban areas, because of various reasons, people are migrating to urban areas. Automatically the stress and water is keep on increasing. keep on increasing, where the contamination of water is reached to the peak levels, and also the consumption also increasing, whereas the quantity of availability is decreasing year by year. Even certain cities, we are unable to get the water at 1500 feet also, even in Andhra Pradesh, even the cities, I mean in India, even in India, metros like see our neighboring states, at metro stations like Hyderabad, water is most scarceful, most desired and most scare. I mean, water is in scare. Water is scare because the population of migrating people, population due to the migration is increasing, and that which in turn leads to burden on water for the for to meet the quality, or as to meet the lifestyle of the urban people. So what I'm saying is here, if you are an appointed environmental engineer, when the water is being calculated for various requirements, or else when the water is being supplied through this water supply system, you must calculate all these demand, all these categories. Then only you are as anyone can supply adequate water to the public. See, so of course, this is the flow chart of water supply engineering. Unless we are not taking care of all these demands, the water supply is not up to mark. So when the water is being supplied, you must calculate the demand, various demands like domestic water demand, commercial demand, and see compensated losses demand, public demand, and all. See, 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 these the water demand is always and always considered as fluctuating parameter. The water consumption is always fluctuated with respect to the season, with respect to water, sir, with respect to season, and with respect to the hours also. See, a season in the sense the demand of water is always fluctuating with respect to season. Season in the sense, normally the consumption of water is more during the during the summer period, and consumption of water is very less and in the areas in winter, during winter season. Whereas in the winter, I mean in certain countries, the consumption of water is very minimum, very minimum. That means what I'm speaking is here, the water demand is always fluctuates with respect to season and with respect to hour. Hour in the sense, during office hours the consumption is more, during non-office hours, that means during at the night or as midnight, the consumption is very low. See, once the water is being supplied through the water supplies, through public water supply system, all these parameters has to be considered. Once you are looking after all these activities. See here, we have seen the flow chart of water supply system, and we have seen various types of water demand. See, and to next class we will discuss the influencing factor of water demand. Already I told you two parameters. That first one is seasonal parameter, means seasonal fluctuations, and the second one is hourly fluctuations, and rest of the things, or if any other parameters which can influence this water demand, we'll discuss in the next class. See, so far we have seen the necessity and importance of protected water supply, objectives of protected water supply system, and waterborne diseases. There we have seen the bacterial diseases, viral diseases, protozoa reasons, protozoa causing diseases, through protozoa, the diseases like amoebiasis we have seen, and also we have seen role of environmental engineer. We have seen the flow chart of water supply system. We may expect a question, a flow chart of water supply engineering or as flow chart of water supply system. Both are same. And the next followed by water demand. There we have seen the 4 or 5 types of water demand: domestic water demand, commercial demand, fire demand, public demand. See here, in the fire demand, you must remember these formulas, Kuchling formulas and for Boston formula. There are number of formulas are there. to estimate the water quantity that is required to control the fire whenever fire accidents are occurred. See here the C5662 root P Boston's formula, where the quantity of water is Q and population of the area P is, and these formulas you must be remembered. All these formulas you may call them as an empirical formulas. In the days to come, you may across so many empirical formulas you need to remember to find out various requirements as part of water supply system. See here, 5% has to be allocated for fire, 45% has to be allocated for domestic, and see here, for this public demand, 5%, again 15% has to be allocated for compensative losses demand. In the next class, we'll discuss about factors influencing water demand. See here, I said that we discussed the hourly fluctuation and seasonal fluctuation must be considered. Even the improper, I mean, the breakage of pipelines also one of the parameters that has to be calculated, that has to be considered once the water is being supplied through the from the water supply system. If you have any doubts, please, you are most welcome. You can ask me and whatever the domain you feel comfortable, either through mail or through message, or else by making a phone call. Thank you, and discuss in next class.